Hi everyone, let's work together on solving some quadratic equations. We will start with the factoring technique. Here is our first example. I wrote out the steps for your reference, but we're going to go ahead and explain them as we solve this equation. We have x squared plus 3x minus 10 equals 0. First, we want to make sure that all terms are on the left side of the equation and listed from highest to lowest degree, and on the other side you have 0 only. Next, we will factor. As you can see, this is an easy trinomial factor. Now, the coefficient is 1, that's what makes it easy. And what that means is that we're going to start off with setting two sets of brackets. So writing up two sets of brackets, and each set of brackets will start with an x. And no matter what quadratic equation you are solving, when the coefficient is 1, this is what you're going to write first. Now we have to think of what numbers to put in each bracket, and the way that we select or we choose those numbers is by looking into the coefficients present in the equation. So we want to find two numbers that have the sum equal to positive 3 and the product equal to negative 10. Now you always start off with the product because there is a limited set of integers that will multiply to negative 10, whereas there is an unlimited set of integers that add to 3. So I always like to start with the smallest factor, which is number 1. And since the product is negative, one number is positive, the other negative. Now, if you were to add these two numbers, the sum will be negative 9, not 3, so that doesn't work. And then we're going to go over the next set, so 2 and negative 5. So 2 and negative 5 multiplies to negative 10. If you were to add them, you get negative 3. We have positive 3. So you should quickly think of switching the signs, making this negative and this positive. And now you have negative 2 plus 5 equal to positive 3. So you're going to write negative 2, positive 5 in here. As you can see, now the equation is in completely factored form. And what that means is that the equation is made of binomials or expressions that are multiplying each other, and here we have 0. So we're going to say that if this factor has a value of 0, multiplied by anything in here will give 0. So we're going to say that x minus 2 equals 0, which happens at x equals 2. Or if x plus 5 is equal to 0, then we'll have 0 times anything, again equal to 0. So we're going to say x equals negative 5. So in this case, we obtained two roots or two solutions, x equals 2 and x equals negative 5. And we're going to say that this equation has two real, distinct roots. Okay, now sometimes people want to be more specific instead of just the word real, which is a more generic word. I can use the word integer. So as you can see, these two numbers are both, or roots are both integers. So to describe the adjective for integers is integral roots. Now this is not the integral we use in calculus. This is just to describe that the two roots are two integers. Let's take a look at another equation. So step number 1, we have to simplify the equation and bring it to standard form, ax squared plus bx plus c equals 0. And it seems that here we have to do a little bit of work for it. Now, we're going to say that 4x squared is already on the left side. Negative 15x is also on the left side. Now negative 3x will come to the left side, become a positive, and negative 9 will become a positive as well. On the right side, we're going to leave 0 only. Now this is not completely standard form. We have to go one more step. 4x squared minus 12x plus 9 equals 0. So let's focus on solving this. We need now to factor completely, and when I look at this equation, I notice that the first term is a perfect square trinomial, as a matter of fact. So 4x squared comes from 2x to the power of 2. And the last term is also a perfect square term, and that is 3 squared. So that's the reason why I am going to check and see if this is a perfect square trinomial. Now, fair warning, just because the first term is a perfect square term and the last is also a perfect square term doesn't guarantee that this is a perfect square trinomial, because we need to have the middle term equal to double of the first with the second, so double 2x and then 3. As you can see here, 2 times 2x times 3 is indeed 12x, which guarantees or proves that this is actually a perfect square trinomial of the form a squared minus 2ab plus b squared. So as you can see, with a equal to 2x and then b equal to 3. So if you have a minus sign in between, it means that we have the a minus b format of this polynomial in factored form. So we're going to go ahead and we'll factor this particular trinomial. So let me just make a little bit of room for us here. Okay, and we're going to factor this as set the brackets. And we know that a minus b squared is simply a minus b times a minus b, with a of 2x and b of 3. We're going to say that 2x minus 3 times 2x minus 3 equals 0 is the factored form. And from here on, we just simply make each factor equal to 0. And, sorry, here we go. And we're going to say that if 2x minus 3 equals 0, x will be equal to, I'm going to go the long way, but you should be able to recognize the zeros very quickly. So x equals 3 over 2. And it's the same thing in here, x equals 3 over 2. So we're going to say that 2x minus 3 is 0, so x is 3 over 2. So we're going to say that in this case, the equation has two real, and see that the roots are the same, so we're going to say equal roots. In our case, the roots are rational, so you can be more specific if you wish to say two rational equal roots. Now next we're going to look into the quadratic formula. So quadratic formula is giving us the root, or gives us the roots of a quadratic equation by simply using the coefficients of the equation when the equation is in standard form. That's very important. So the way that we obtain this quadratic formula is by simply solving this equation using a method that we call completing the square, which I'm going to go over in the next video. So how do we solve by using the quadratic formula? Step number 1, we want to make sure that the equation is in standard form, which means that all terms on the left, just that 0 on the right, and all terms listed from highest to lowest degree. Makes it easy for us to identify the coefficients. Now, as you can see here, we have the coefficients a equals 2, b equals positive 9, and c equals negative 5. So we are going to substitute them into the formula very quickly. And let me just actually color code them a little bit so that we can look at a easy to follow solution. So now we have x equals, I'm going to draw a big fraction line, and now we're going to put in negative b. Now the value of b is positive 9, so negative b will be negative positive 9, which is negative 9. And then we have plus or minus, so plus or minus, we have the square root here of b squared, that means we have 9 squared, minus 4, so this number 4 here, multiplying a, multiplying c. So the value of a is 2, and the value of c is negative 5. I'm going to make this root a little bit longer to show that all these numbers are inside the root. That is very important, and its proper form. And this is over 2 times a. So, and the value of a is obviously 2. So here we go. We have negative 9 plus or minus. So 9 squared is 81. 4 times 2 times negative 5 is 40. So the entire expression inside the radical, or as we call it, the radicand, is 121 divided by 4. Continue simplifying as much as you can. And here we go. We're going to get in here. Sorry, I keep doing this, running out of space. And we have negative 9 plus or minus. So fortunately, this is going to be a perfect square, so we can take it out of the roots fully. And then we have over 4. Now we are ready to state each solution. And we're going to say that x1 is negative 9 plus 11 over 4. And x2 would be equal to, I'm going to put this one this way here. And x2 would be equal to negative 9 minus 11 over 4. So simplify a little bit more. Negative 9 plus 11, that would be equal to positive 2 over 4. Negative 9 minus 11 is negative 20 over 4. Definitely simplify the roots fully. So this will reduce to 1/2, and this will be negative 5. So in this equation, we have two real distinct roots, or two rational integral, just use the word real, distinct roots. Okay, so now let's take a look at another equation. So we're going to put this one, we're going to tuck it in on the side here. Let's move on to the next example. Now here we go. We have x squared plus 8 equals 2x plus 5. So x squared plus 8. Now 2x comes to the other side, and so that's positive 5, and they both have to switch their signs to opposite. So we have x squared. Now we're going to put them from highest to lowest degree, minus 2x. 8 and negative 5 will reduce, or will simplify to positive 3. Now we'll identify the coefficients. We have the coefficient A equal to 1, coefficient B equals negative 2, and coefficient C is positive 3. So we'll substitute everything into the formula. X equals, we have negative B, so negative 2. And then plus minus the square root, a big square root sign in here, big fraction in here. So we'll have negative 2 raised to the power of 2. Minus 4 multiplying A is equal to 1. And then this will multiply C, which is positive 3. And this will be our over 2 times A, which is 2 times 1. So X equals negative 2 will make a positive 2, plus or minus. Negative 2 squared is 4, and 4 minus 12 will be negative 8. That is inside the square root divided by 2. Now we'll continue simplifying this number. We know how to simplify radicals. So this is a radical. It's also an imaginary term, so it doesn't exist in the real set of numbers. But we still have to simplify it. So we have the square root of 4, the square root of negative 2 divided by 2. The square root of 4 will simplify to positive 2, root of negative 2 divided by 2. Now, in the next step, we will want to factor out the 2 from the numerator. As you can see, this is one term, so it's its own factor. And here we have a factor of 2 multiplied by root of 2. So 2 is a common factor. So we'll take that out. And then we'll have 1 plus or minus the square root of negative 2 divided by 2. We simplify now the denominator, and we'll end up with 1 plus or minus root of negative 2. So now we're going to state each root. It is very important you complete this step. This is not considered complete because there is another concept that we're testing, and we want to know if we understand well how to determine the roots from here. So how to split this or use this expression. So this will be 1 plus square root of 2, and this is 1 minus square root of negative 2. Okay, as you can see here, we obtain two roots. They are distinct and they are non-real, or you can call them complex. Non-real roots always are distinct because if you think about it, they come from adding and from subtracting that same number. So that's what makes these two different numbers. Now, these are the two methods, the factoring and the quadratic formula techniques that we use in solving quadratic equations. And I will explain the next method in the next video. See you soon.